Namaskar. In the last lecture, we have studied inverse trigonometric functions. Definitions: we have obtained their domain, range of inverse trigonometric functions. Now, in today's lecture, we will learn properties of inverse trigonometric functions. I will just state these properties. I will not give proofs of these results. And after stating these properties, we will solve problems which are based on these properties. Our main aim is to solve problems on inverse trigonometric functions, and for solving this problem we have to simplify them, and for simplification purpose we will use properties of inverse trigonometric functions. First property is if x lies between -1 and 1. If x lies between -1 and 1. This is condition. Why this condition? Because x should be in the domain of inverse sine function. So if x lies between -1 and 1 and x is not equal to 0, then sine inverse x is equal to cosec inverse 1 upon x. How can we use this property for solving problem? Sometimes we may write sine inverse 2 by 3 as cosec inverse 3 by 2. Sine inverse 2 by 3 is equal to cosec inverse 3 by 2. So this is first property of inverse trigonometric functions. So this way I will state some properties and then we will move to problems. Second property is cos inverse x is equal to sec inverse 1 upon x. Here also we have restriction on x, and that restriction is x should lie between -1 and 1 and x should not be 0. Why x is not equal to 0? Why x should not be equal to 0? Reason is we are writing 1 upon x, and if x is equal to 0, that 1 upon x will not be defined, and therefore we want this x not to be 0. Why we want x between -1 and 1? Because -1 to 1, closed interval -1 to 1 is domain of this cos inverse function or sine inverse function. We cannot ask this property cos inverse of 3 is equal to, because 3 is not in the domain. Therefore these two conditions are there. Now third condition, third property, tan inverse x is equal to cot inverse 1 upon x if x is greater than 0. Now here in first and second property, negative x was allowed, means we could ask cos inverse of -2 by 3, cos inverse -2 by 3, but this property will not work. Tan inverse -2 by 3 हे नाही चालणार इथे, because -2, this property is for positive x only. And what to do if we want to simplify tan inverse -2 by 3? Then we have another property for that. That property is tan inverse x is equal to -pi plus cot inverse 1 upon x. Tan inverse x is equal to -pi plus cot inverse 1 upon x if x is negative. म्हणजे x पॉझिटिव्ह असेल तर tan इनवर्स x ला असं लिहू शकतो आपण, आणि x जर निगेटिव्ह असेल तर त्याच tan इनवर्स x ला आपण असं सिम्प्लिफाय करतो. मी एक एक्झाम्पल सांगतो तुम्हाला. tan इनवर्स -2 by 3, tan inverse -2 by 3, we cannot simplify that tan inverse -2 by 3 by using this formula. We have to use this one. So tan inverse -2 by 3 is equal to -pi plus cot inverse -3 by 2. Reciprocal of -2 by 3 is -3 by 2. Okay, then let us move to next property. If x lies between -1 and 1, then sine inverse -x is equal to minus sine inverse x. So I can write sine inverse of -1 by 2, sine inverse of -1 by 2 as minus sine inverse 1 by 2. This property will help me in finding principal values. Now what is your guess for cos inverse minus x? What is your guess for cos inverse minus x? तुम्ही गेस करून सांगू शकता का cos inverse minus x is equal to काय असेल? नाही, चुकला तुमचा गेस. चुकला, wrong. Correct answer is, if x lies between minus 1 and 1, then cos inverse minus x is equal to pi minus cos inverse x. Cos inverse minus 1 by 2, cos inverse minus 1 by 2 is equal to pi minus cos inverse 1 by 2. अशी ही प्रॉपर्टी आहे, थोडी वेगळी आहे. सहावी प्रॉपर्टी, for all x belongs to R, tan inverse minus x is equal to minus tan inverse x. सगळ्या x करता ही प्रॉपर्टी खरी आहे. if mod x is greater than 1, means x may lie to the right side of 1 or to the left side of minus 1, then cosec inverse minus x is equal to minus cosec inverse x. Next, if mod x is greater than 1, why this condition is there? Because x should be in the domain of inverse cosec function, inverse sec function. That is why this condition is there. Sec inverse of minus x is equal to pi minus sec inverse x. So if I want to write sec inverse minus 2, I can read it as pi minus sec inverse 2. So for simplification of these inverse functions for negative values, we may use this property number 4, 5, 6, 7, 8. For all x belongs to R, cot inverse minus x is equal to pi minus cot inverse x. This is true for all x belongs to R. Domain of cot function is R. Inverse cot function is R. Domain of inverse tangent function is also R. Domain of inverse cos function is closed interval minus 1 to 1. Therefore, x should lie between minus 1 to 1. Next, if x lies between minus 1 and 1, then sin inverse x plus cos inverse x is equal to pi by 2. If x lies between minus 1 and 1, then sin inverse x plus cos inverse x is equal to pi by 2. 11th property, if x belongs to R, then tan inverse x plus cot inverse x is equal to pi by 2. And similar to these 10th and 11th, we have 12th property. For x greater than 1, cosec inverse x plus sec inverse x is equal to pi by 2. Cosec inverse x plus sec inverse x is equal to pi by 2. Next, if x, y are positive, real numbers and their product xy is less than 1. Now see the conditions. If xy are positive and product xy is less than 1, then tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So if I have x is equal to 1 by 2, y is equal to 1 by 3, 1 by 2, 1 by 3 are positive numbers, and their product xy is less than 1, then I can write tan inverse 1 by 2 plus tan inverse 1 by 3 as tan inverse of a single number. That single number is 1 by 2 plus 1 by 3 upon 1 minus 1 by 2 into 1 by 3. This formula can be used if x, y are positive and their product x into y is less than 1. What if product xy is greater than 1? We cannot use this formula. There is another formula for that. So here if xy are positive and xy is greater than 1, xy are positive and xy is greater than 1, then this tan inverse x plus tan inverse y is equal to not only tan inverse x plus y upon 1 minus xy, but it is equal to pi plus tan inverse x plus y upon 1 minus xy. So this pi comes in addition if xy is greater than 1. These properties are applicable if x, y are positive. What if they are negative? जर हे एक्स वाय निगेटिव्ह असतील तर काय? तर ह्या दोन्ही प्रॉपर्टीज आपण वापरू शकत नाहीत, हे फॉर्म्युले वापरू शकत नाहीत. आपल्याला ते नंबर त्यातले मायनस साईन योग्य पद्धतीने बाहेर काढून घ्यावं लागेल. कसं? तर त्याकरता आपल्याकडे प्रॉपर्टीज आहेत ना इथं. हे इथं टॅन इनवर्स मायनस एक्स, हे मायनस साईन बाहेर काढणार. कॉट इनवर्स मायनस एक्सला पाय मायनस कॉट इनवर्स एक्स असं लिहिणार आपण. तर ह्या प्रॉपर्टीचा वापर करून आपल्याला मायनस साईन पहिल्यांदा बाहेर घ्यायला लागेल आणि मग सिम्प्लिफाय करू. सो दीज आर सम प्रॉपर्टीज. आय थिंक वन मोर प्रॉपर्टी इज देअर. इफ एक्स पॉझिटिव्ह, वाय पॉझिटिव्ह, but their product is neither greater than 1 nor less than 1. Product is equal to 1. Product is equal to 1. Then tan inverse x plus tan inverse y is equal to pi by 2. Tan inverse x plus tan inverse y, this is equal to pi by 2. For that, product xy should be equal to 1. X, y both should be positive. Okay. Then next, if x, y are positive, x, y are positive, then tan inverse x minus tan inverse y, whatever may be the product xy, xy may be less than 1, may be greater than 1, tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy. Next, now we will solve some examples. These are properties. Using these properties, we have to solve some problems. First problem is find the principal values of the following. 3 sums are given. 3 problems दिलेले आहेत. First problem is sin inverse minus 1 by 2. I will solve one problem at a time, one by one, to find the principal value of sin inverse minus 1 by 2. Principal value of this is equal to angle theta, for which sin theta is equal to minus 1 by 2 and theta lies in the principal domain of sine function, which is closed interval minus pi by 2 to pi by 2. म्हणजे आपल्याला फर्स्ट क्वाड्रंट किंवा फोर्थ क्वाड्रंट मधला एक अँगल पाहिजे की ज्या अँगलचा साइन रेशो -1 by 2 येतो. आपल्याला एक गोष्ट माहिती आहे, साइन 30 डिग्री इज 1 by 2. Sin 30 degree is 1 by 2 and 30 degree in radian we read it as pi by 6. So sin pi by 6 is 1 by 2 and sin minus theta is minus sin theta. So sin of minus pi by 6 is equal to minus 1 by 2. This minus 1 by 2 is between minus 1 to 1 and minus pi by 6 angle lies in the principal domain of sine function. Therefore, we can invert this relation, and inverting this relation we can write sin inverse minus 1 by 2 is equal to minus pi by 6. We can write it as sin inverse minus 1 by 2 is equal to minus pi by 6, and this is the principal value of sin inverse minus 1 by 2. This is the principal value. तर ही प्रिन्सिपल व्हॅल्यू कशी काढायची याबद्दलची माहिती सांगितली. आता या दुसऱ्या प्रॉब्लेममध्ये आपल्याला cos इनवर्स √3/2 ची प्रिन्सिपल व्हॅल्यू काढायची. कॉस इनवर्स √3/2 ची प्रिन्सिपल व्हॅल्यू काढायची म्हणजे असा एक अँगल शोधून काढायचा की ज्या अँगलचा कोसाइन रेशो √3/2 आहे आणि तो अँगल कोसाइन फंक्शनच्या प्रिन्सिपल डोमेनमध्ये असलं पाहिजे. प्रिन्सिपल डोमेन ऑफ प्रिन्सिपल डोमेन ऑफ कोसाइन फंक्शन इज क्लोज्ड इंटरवल 0 to π. म्हणजे फर्स्ट क्वाड्रंट किंवा सेकंड क्वाड्रंटमध्ये आपल्याला असा अँगल पाहिजे की ज्याचा कोसाइन रेशो √3/2 आहे. आणि आहे ना, आपल्याला माहिती आहे cos 30 डिग्री मीन्स cos π/6 इज इक्वल टू √3/2. मी हे पुढच्या स्लाइडवरती लिहितोय. cos π/6 इज इक्वल टू √3/2. π/6 is in the principal domain of cosine function. π/6 is in principal domain of cosine function. Therefore, we can invert this relation, and inverting this relation, we can write cos inverse √3/2 is equal to π/6. So, this π/6 is the principal value. The principal value of cos inverse √3/2 is π/6. Third sum is cot inverse minus 1/√3. आपल्याला हा अँगल माहिती आहे 2π/3 means 120 डिग्री. cot 120 डिग्री means cot 2π/3 is equal to minus 1/√3. you can see this from table. आपल्याला जे ट्रिगोनोमेट्रिक ह्याची टेबल आहेत त्या टेबलमध्ये तुम्ही पाहू शकता व्हॅल्यू. त्या व्हॅल्यूमधून तुम्हाला हा अँगल मिळेल 2π/3 120 डिग्री. And this 2π/3 lies between 0 to π. 2π/3 lies between 0 to π. 0 to 180 च्या मध्ये आहे 120 डिग्री. हा 120 डिग्री अँगल 0 पेक्षा मोठा आहे, 180 पेक्षा लहान आहे. इनवर्स कॉट फंक्शनचा डोमेन प्रिन्सिपल डोमेन हा क्लोज्ड इंटरवल 0 to π आहे. कॉट फंक्शनचा प्रिन्सिपल डोमेन 0 to π आहे. इनवर्स कॉट फंक्शन जो आहे त्याची ही रेंज आहे 0 to π, म्हणून हा अँगल आपल्याला 0 to π मध्ये असावा लागतो आहे. आय कॅन इन्व्हर्ट दिस रिलेशन अँड राईट दिस ॲज cot inverse of minus 1/√3 is equal to 2π/3, and therefore 2π/3 is the principal value of cot inverse minus 1/√3. So this is how to find principal values. हे 2 मार्काकरताचे प्रश्न असतात परीक्षेमध्ये, 1 किंवा 2 मार्काकरता हा प्रश्न विचारला जाऊ शकतो. प्रिन्सिपल व्हॅल्यू काढा. टेबल असेल तर आपण सहजपणे हे करू शकतो. प्रॉपर्टीचा याच्यामध्ये उपयोग आपल्याला करावा लागतो. आता प्रिन्सिपल व्हॅल्यू सारखाच हा एक छोटासा प्रश्न आहे. फाइंड द व्हॅल्यूज ऑफ द फॉलोइंग. साइन इनवर्स साइन 5π/3. If this angle is in the principal domain of the sine function, then we can easily simplify it. But if this angle is not in the principal domain of sine function, if this angle doesn't lie between minus π/2 to π/2, then we need more simplification, further simplification for this. Now what simplification we have to do? Let us see. These are 4 problems, 4 questions. I will write solutions of these 4 questions one by one. Sin inverse 5π/3 is equal to sin inverse sin 5π/3 is equal to sin 2π minus π/3. Sin 2π minus theta is equal to sin theta. Sin 2π minus theta is equal to sin theta. And why I am doing it like this, why I am writing it like this? Because this 5π/3 is not in the principal domain of sine function. So I take this and now I get angle minus π/3. This difference is minus π/3. ही जी वजाबाकी आहे ही वजाबाकी minus π/3 येते. Now here I am using the property sin 2π plus theta is equal to sin theta. So sin ratio of angle minus π/3 is same as sin ratio of 5π/3. म्हणजे 5π/3 आणि -π/3 हे अँगल कोटर्मिनस अँगल आहेत. and angle -π/3 is in the principal domain of sine function. Therefore I can write this as -π/. This is the solution. Here problem completes. इथे प्रॉब्लेम हा संपतो आहे. मी सेकंड, थर्ड, फोर्थ प्रॉब्लेम जे आहेत यांचे सोल्युशन पुढच्या लेक्चरमध्ये सांगणार आहे. तोपर्यंत नमस्कार.